We have seen how to create linked list by inserting noded tail. To add single noded tail in single linked list, every time we need to find the tail node. It will take n comparisons if we have n nodes within our linked list. So insertion at tail will take big of n time. Instead of inserting new node at the end of the list, if we insert node at start of the list, means at the head position, it will take only constant amount of time, means it will take big of one time. For more details about insertion at tail in linked list, video link is provided in the description of this video. Now let us see how to insert node at the head of the linked list. If we want to add one element to our linked list, we need to allocate memory dynamically. This create node function will allocate memory for linked list node and heap by using malloc function. Base address of allocated memory will be stored within this new node pointer. If we wanted to add element 1, here that value will be stored within this new node data field. Initially newly created node next part will be null. This create node function will return new node address. So this new node pointer in this insert head function will be pointing to newly created node. Initially global variable head will be null, means linked list is empty. We are going to add this newly created node as first node within our linked list. Here this head is null, so make this new node as head. So here head is assigned with new node address. Now this head is pointing to this first node. Again we want to perform this insert head operation. So new node will be created. Suppose we enter new node data 2 and its address is stored within this new node pointer. Here head is not null. So add this newly created node as first node within our linked list. While inserting node at tail, we need to find the last node within our list. But here we can simply place this head address in the new node link field. Then this new node will be added to already existing list. That can be done by storing head address in the new node next field. Now see here, new node next has this head address 1024. Previously it was null. Now this new node is added to list. But see here, this is the first node within our linked list. Still head is pointing to this node. We need to update the head. So update the head value with new node address. Here it is 1040. 1040 is stored within the head. Previously it was 1024. Now this head is pointing to this first node. Similarly for this insert head operation also, new node will be created. Again here head is not null, means linked list is not empty. This else block will execute. Add this newly created node at the starting of our list by storing the head value in the new node next field. Again we need to update this head because this is the first node. That can be done by storing this new node address within the head. Now this head is pointing to this first node. In short, you can even write code like this also for insertion at head function. This code will also work same as this code. See here, when head is null means linked list is empty. What we are doing here, we are simply adding new node address in the head. Suppose even if we add this statement, there will be no difference since here head is null. Null will be stored within the new node next field. While creating new node, we already added null into next field. Same will be overridden. Within the next field, again null is placed. Here we have same two statements in this if and else also. So instead of writing code like this, simply we can write code like this. This is the complete program for linked list creation by inserting at head. Include this header file to use dynamic memory allocation functions. This is the node structure for single linked list. Initially head will be null, means no elements are added to linked list. At compile time, memory will be allocated automatically for arrays, but for linked list we need to allocate memory dynamically. This create node function will allocate memory on heap by using this malloc function. Malloc function will return base address of newly created block of memory. If malloc fails to allocate memory, it will return null. If malloc return null, it means there is no free space in heap area. So we need to raise this error. The allocated memory base address will be stored within this new node pointer. With this new node pointer, we can add data into our linked list. Here we are taking the user input and we are adding the data into the new node data field. Initially new node next field will be null. Finally new node address will be returned to calling function. This is the insert head function. Insert head function will call create node function that will return newly created node address. If head is null, means linked list is empty, then our newly created node is the first node to be added in the list. So make new node as head. If list is already has some elements, then add existing list in newly created node next field. So here we are placing head address in the newly created node next field. Then update the head because new node added at the starting position of our linked list. This display function will print the contents of list. We need to check whether linked list is empty or not. If list is not empty, we need to print the contents of the linked list. To print the contents of linked list, this while loop will print the node data, then advance the temp pointer until temp not equal to null. If we execute this program, here we are calling insert head function 3 times. Enter the input. Then this is our list. This 2 added before 1. Similarly 3 added before this 2 and 1 because we are inserting new node at the starting of our list.